Hey, how you doing? We're going to take a look in the transformer lab. This is where Jack has been doing all his videos, and come on in. I'm going to show you. We're going to use the transformer lab to set up actually some of the rectifier labs for electronics. So come over this way and take a look around. This is a nice area. Down in the far end is the AC machines where the motors and things are, and in this area, this is where all the transformer benches are. And so come on in, wind your way through here, and I'm going to show you what we're doing with the electronics labs, the electronics rectifier labs. All right, come over this way. So I'm set up in here, and basically I've got the transformer bench. These upper bars are completely insulated and isolated bars. We just hook power up to them. Right now I've got this hooked up for just a single phase rectifier that I'm working on, but you can see that this is good for four wire circuits, 3-phase 4-wire, and these are the 3 transformers. And so these are the rectifier boards right here. So come in and take a nice close look at this. These rectifier boards all have 6 diodes, and each diode is threaded. These are stud type diodes, and they thread into this aluminum block. And I'm going to show you the data sheet a little bit later for these. And the data sheet, according to the data sheet, the threads or the case on these diodes, I'm going to turn this off just to make sure I don't touch anything I shouldn't. This casing part that screws into this is actually the cathode, so cathode to case. And that means that this top part here that's soldered, this wire is soldered onto, that's the anode, okay? So, the cathodes, interestingly enough, are brought out, in this case, to some red terminals. Now that doesn't really mean anything. These are still, the cathodes is the N-type material, so if you wanted to forward bias these diodes, this has to be negative. And then we go from the anode. The anode is on the top of all these diodes, and it's wired into this fuse. These fuses are here to protect these diodes, make sure that if there's too much current, fuse opens up instead of taking out the diode. And then there's our other lead. So what I'm going to do, let me just show you quickly. I'm going to take a meter here, and I want to show you, if I can get this meter out of here. I want to show you what the readings will look like if we do a test on one of these diodes. And so let me just set this up right here. What you do is you set your meter up. You choose the diode setting on the meter, which is right here. You can see that little diode setting right there. And so on this case, now I'm going to take my leads and I'm going to place them. Now I want to go with, when you're testing a diode, you got to realize this lead right here is coming from my negative point on my meter. And so I want that to go to the cathode. So in this case, we already discussed this, the cathode's on top. So I'm going to plug that in up there. And now I'm going to take this lead, which is my positive lead, and I'm going to go to the anode. We already said this is right on top. Now watch this meter real closely. Nice close shot on this meter, okay? And if you touch this, you're going to see that there's a voltage drop of 4.6 volts about. And that actually shows you the voltage drop. It's really the barrier voltage across that diode. And so what it tells you is that diode is operating properly, and it shows you the actual barrier voltage drop. Now, if I switch these leads, and you know, when you test a diode, it's just as important to test it both ways. And so, because a diode can be actually open or it can be shorted. So you got to make sure that it conducts one way and that it does not conduct in the other way. So look at this. Now I've changed my leads around and I get absolutely nothing there, which means that this diode is in good condition. It conducts the one way and it blocks the other way. And that's exactly what it's supposed to do. Now, I always also, before I start hooking these up, I also test the fuse. And so, you know, we just do a quick test on each one of them, and then we can go ahead and hook these up. You know, regardless if it's a single phase half wave, we just need one. If it's a single phase full wave, then we need 4. If it's a center tap single phase, then we need 2. If it's a 3-phase half wave, then we need 3. And only when it is a 3-phase full wave, then we use all 6 diodes. So these boards are capable of doing any of the rectifier circuits that we want to do. So just nice for you to get in here and have a look. Yeah, we have all the meters here. These meters I hook up to show voltage, current. I've got the scope in here so we can look at the waveforms, and everything is arranged in fairly tight spaces for filming here right now for doing the videos. But it's a nice lab, and I wish you could spend some time here. But as it is now, you're just going to have to watch these videos, and you'll get a pretty good idea of what's going on in here. All right, thanks for watching.